Welcome to our deep dive into the secrets behind Mars a red color.
Oh, yeah?
We've got some fascinating studies from proceedings of the National Academy of Sciences and Nature Communications to unpack.
Okay.
You know how Mars is called the red planet? Well, these studies shed light on why that is and hint at something even more amazing. The possibility of ancient oceans and maybe even life.
It's really intriguing, actually.
Yeah.
We've always thought of Mars as having this dramatic shift from a warm and wet world to the cold and dry planet we see today.
Yeah, exactly. Like it lost its paradise over time.
That's the common picture, yes.
Yeah, right.
But these studies are suggesting something different.
Okay.
A Mars that was likely cold and
Hold on. A cold and wet Mars.
Yeah.
That changes everything. I'm all ears.
Okay.
Tell me more.
Well, one study focuses on data from the Chinese rover,
Okay.
Zhurong, exploring a region in Mars's northern lowlands.
Mm-hmm.
They were using ground-penetrating radar and stumbled upon something pretty amazing.
Okay.
Evidence of a massive sloping region buried underground.
Ooh, this is where I get to guess right.
Uh,
Is it an underground Martian city or a giant network of ice caves?
Not quite, but still amazing.
Okay.
Everything about this formation, its shape, the sediment composition, points to it being an ancient beach.
Wow.
Think gentle slopes of sand and pebbles, just like you'd see on a coastline here on Earth.
Wow, an ancient beach on Mars. That's incredible. Does that mean there was a vast ocean covering that part of the planet? I mean, on Earth, beaches mean oceans, right?
It's not absolute proof, but it's a huge piece of the puzzle.
Oh, okay.
It makes you wonder if Mars really did have a giant ocean sloshing around billions of years ago.
Yeah.
And if you think about it, beaches on Earth are where some of the first life forms appeared.
Right.
So this discovery opens up some truly exciting possibilities about ancient life on Mars.
Okay, so we've got this possible ancient beach on Mars.
Yeah.
But that brings me back to my initial question. Why is Mars so red? Everyone knows it as the red planet, but what's the science behind that rusty color?
For a long time, scientists believed that the red color came from hematite,
Okay.
which is a type of iron oxide or rust that forms without water.
Okay.
It seemed to fit with the picture of Mars as this dry, rusty world.
That makes sense. Iron and oxygen rust, it all adds up.
Yeah.
But I have a feeling it's not that simple, is it?
You're absolutely right.
Okay.
This new study actually suggests that the red color we see might come from a different culprit,
Uh-oh.
a type of rust called feryhydrate.
Feryhydrate. Okay, that one's new to me. What's the difference between that and regular old hematite?
Well, feryhydrate is still a type of rust,
Okay.
but here's the catch. It actually contains water molecules. This means it had to form in a wet environment.
Oh.
Quite different from the dry conditions we thought were responsible for Mars's red hue.
Wait, so the rust we see on Mars today actually needed water to form? That's completely different from what I thought.
It is.
Yeah.
And it gets even more interesting.
Okay.
The study suggests that this feryhydrate likely formed in cold acidic water. What's fascinating is that those specific conditions would keep the feryhydrate stable for billions of years,
Wow.
explaining why we still see that red color across Mars today. It's like a planetary scar,
Yeah.
telling the story of a cold, wet past.
Okay, my mind is officially blown.
Yeah.
We've got a possible ancient beach AND, a mineral that forms in cold water. This is not the Mars I learned about in school.
Exactly, and that's what makes these studies so exciting.
Yeah.
They paint a picture of early Mars that was both wet and cold.
Okay.
Potentially with a vast, chilly ocean lapping at icy beaches.
Wow.
It's a completely different image from the warm and wet paradise we often imagine.
So if Mars really was this cold and wet world billions of years ago, what kind of life could have existed there? Was it teeming with strange creatures, or are we thinking more along the lines of tiny microbes?
That's a fantastic question. And, you know, on Earth we have these incredible organisms called extremophiles
Right.
that thrive in conditions most life forms would find deadly. They exist in extremely hot or cold places,
Right.
in highly acidic or salty environments,
Yeah.
proving that life is incredibly adaptable.
You're telling me there's life on Earth that could chill in a Martian hot spring or a super salty Martian lake? That's amazing.
Exactly. And that's why this picture of a cold and wet Mars is so compelling.
Yeah.
It raises the possibility that similar extremophiles might have evolved on Mars,
Right.
surviving in those harsh conditions billions of years ago.
Okay, I'm officially hooked. You've just opened up a whole new world of possibilities for me.
Good.
But if these resilient life forms could have existed on Mars, how would we even find evidence of them? It's not like we can just go digging for fossils in a Martian backyard.
Right.
Or can we?
Well, that's where things get even more challenging. We have to rely on sophisticated instruments and techniques to analyze the Martian environment and look for signs of past life.
So instead of digging for bones, we're looking for other clues that might point to ancient life. Like what? Martian footprints in the sand?
Not quite footprints, but you're on the right track.
Yeah. Okay.
Scientists look for what are called biosignatures, any substance, pattern, or phenomenon that provides scientific evidence of past or present life.
Okay.
They can be physical, chemical, or even isotopic in nature.
Yeah, okay.
Think of it like a detective searching for fingerprints at a crime scene.
Yeah.
But instead of a crime, we're looking for the fingerprint of life itself.
Okay, I get it. It's not just about finding a fossilized Martian microbe.
Right.
There are other clues that can point to the existence of past life.
Mm-hmm.
Give me some examples. What kind of biosignatures are scientists looking for on Mars?
One example is organic molecules,
Okay.
the building blocks of life as we know it.
Okay.
Finding complex organic molecules on Mars would be a strong indicator of past life.
Yeah.
Although it wouldn't be conclusive proof,
Right.
as they can also be formed by non-biological processes.
Right, because we need to be sure those organic molecules weren't just created by some random chemical reactions.
Yeah.
So what else are they looking for?
Another key biosignature is something called isotopic ratios.
Okay.
Think of isotopes as atoms of the same element, but with slightly different weights.
Okay.
Living organisms tend to prefer certain isotopes over others.
Hmm.
So finding unusual isotopic ratios in Martian rocks or soil could suggest biological activity.
Okay.
It's like looking for a specific fingerprint that only life can leave behind.
Okay, I see what you mean. So it's like a puzzle.
Right.
Each piece of evidence, the beach, the feryhydrate, these biosignatures, brings us closer to the bigger picture of whether life ever existed on Mars.
Yeah.
And the more pieces we find, the clearer that picture becomes.
Exactly. And each mission to Mars is like adding another piece to that puzzle.
Right.
The more we learn, the closer we get to answering one of the biggest questions humanity has ever asked.
Which is?
Are we alone in the universe?
This is all so fascinating, but now I'm even more curious.
Okay.
Has anyone actually found any conclusive evidence of past life on Mars yet? Have we found those Martian microbes?
That's the million-dollar question.
And the answer is not yet.
Oh, come on. Don't leave me hanging. What are some of the most promising hints we've found?
Well, one of the most intriguing discoveries came from the Curiosity rover,
Okay.
which detected methane in the Martian atmosphere.
Okay.
As we discussed earlier, methane can be a sign of biological activity.
Right.
However, it can also be produced by geological processes.
Hmm.
So we need more evidence to confirm its origin.
So it's like finding a smoke signal, but not knowing if it came from a campfire or a volcano?
Right.
We need more clues to solve the mystery.
Precisely. And remember, Curiosity also found organic molecules in Martian rocks,
Yeah.
another potential biosignature. But again, these molecules could have formed through non-biological processes.
Right.
It's like having the ingredients for a cake, but not knowing if anyone actually baked it.
So we have these tantalizing pieces of evidence, but we're still waiting for that smoking gun.
Yeah.
That undeniable proof that life once existed on Mars.
Is there anything else that might help us find it? Any other missions on the horizon?
Absolutely. The Perseverance rover is currently exploring Jezero Crater,
Okay.
which scientists believe was once an ancient lake bed. It's equipped with cutting-edge instruments to search for biosignatures and collect samples that will eventually be brought back to Earth for further analysis.
Hold on, we're bringing Martian samples back to Earth. That's incredible. So we're talking about actually analyzing pieces of Mars in our labs. Tell me more about that mission.
It's called the Mars Sample Return Mission,
Okay.
and it's a joint effort between NASA and the European Space Agency. It's an incredibly ambitious project that involves launching a spacecraft to Mars,
Yeah.
collecting the samples Perseverance has cached, and bringing them back to Earth for detailed analysis.
Wow, this is getting better and better. Imagine we bring those samples back and boom! We find definitive evidence of past life.
That would be awesome.
Tiny fossilized Martian microbes preserved for billions of years, finally revealing their secrets. Talk about a scientific mic drop.
That would be a truly groundbreaking discovery.
Yeah.
It would revolutionize our understanding of life in the universe and our place within it.
Right.
We'd no longer be the only known example of life in the vast cosmos. It would spark a wave of new research and exploration as we try to understand the nature and diversity of Martian life.
Okay, I'm officially geeking out here, but let's reel it back in for a second.
All right.
Even if we don't find fossilized Martian microbes in those samples, there's still so much we can learn from them, right?
Absolutely. Analyzing those samples will provide a wealth of information about the Martian environment, its history, and its potential for habitability.
So it's a win-win situation no matter what we find.
Yeah.
Either we make history with the discovery of Martian life, or we gain valuable insights that will guide future missions and research.
Exactly. The Mars Sample Return Mission is a testament to our relentless pursuit of knowledge and our desire to explore the unknown. It shows just how far we're willing to go to answer those fundamental questions about life beyond Earth.
All right, so we've covered a lot of ground in this deep dive so far.
We have.
We've talked about the evidence of ancient oceans on Mars, the possibility of extremophile life, and the ongoing search for biosignatures.
Right.
But before we wrap up this part of our journey, I have one final question for you.
Okay.
What's next for Mars exploration? What are the big questions that still need to be answered?
Well, one of the biggest questions, of course, is whether life ever existed on Mars. While we have those intriguing hints,
Right.
we still need conclusive evidence.
Yeah.
Finding those fossilized Martian microbes would be the holy grail of Mars exploration.
That's right. Finding that definitive proof would be a game changer.
Yeah.
But what if life on Mars wasn't just a thing of the past? What if it still exists today, hidden beneath the surface, away from the harsh conditions above?
That's another fascinating question. Could there be subsurface environments on Mars that are still habitable today? Perhaps underground aquifers or hydrothermal vents where life could have found refuge as the planet's surface became less hospitable.
I'm picturing a whole hidden ecosystem beneath the Martian surface. Maybe there are even cave-dwelling Martian creatures that have adapted to the darkness and isolation.
It's certainly possible.
Yep.
And that's why future missions will likely focus on exploring these subsurface environments. We need to drill deeper, both literally and figuratively,
Yeah.
to understand the full potential of Mars.
Okay, so you need to send some spelunking robots to Mars.
Right.
I'm all for that.
Good.
But what about the big picture? What about human missions to Mars? Is that still on the table?
Absolutely. Human exploration of Mars is the ultimate goal,
Okay.
and agencies like NASA and SpaceX are actively working towards making it a reality. Imagine humans walking on Mars,
Wow.
conducting research, and perhaps even establishing a permanent presence.
I can't even imagine what it would be like to be the first human to set foot on Mars. Talk about a giant leap for humankind.
Yeah.
But before we send humans to Mars, we need to make sure it's safe, right? I mean,
Yeah.
we don't want to end up like Matt Damon and the Martians, stranded and growing potatoes in our own ways.
All right. Safety is paramount.
Yeah.
We need to develop technologies and strategies to mitigate the risks of radiation, isolation, and the harsh Martian environment. It's not just about getting there.
Right.
It's about surviving and thriving once we do.
So it's not just about planting a flag on Mars.
Right.
It's about building a sustainable presence, a new home for humanity among the stars.
Exactly. And that's why research on Mars is so crucial.
Okay.
The more we learn about the planet,
Yeah.
the better prepared we'll be for human missions.
Okay. I'm officially ready to pack my bags and head to Mars.
Good.
But before I do, I have one last question for you.
Right.
What's the one thing you want our listeners to take away from this deep dive? What's the most important message about Mars exploration?
I think the most important message is that Mars is a dynamic and fascinating world, full of mysteries, waiting to be uncovered. It's a planet that has captured our imagination for centuries,
Yeah.
and it continues to inspire us to push the boundaries of science and exploration.
Well said. And who knows, maybe one day you'll be the one making those groundbreaking discoveries on Mars, unraveling the secrets of the red planet, and perhaps even finding evidence of life beyond Earth.
Oh, that would be amazing.
It would.
I hope so.
Yeah, I think everyone's hoping for that.
I think so too.
Well, this has been incredible.
Yeah, it has.
I've learned so much.
Good. I'm glad to hear that.
But we'll have to continue this conversation in our next deep dive.
Okay, sounds good.
All right, so until next time, keep looking up at the stars and keep asking questions.
Yes,
Because the universe is full of wonders waiting to be uncovered.
it is.
We'll see you next time.
See you then. It really is incredible to think about, isn't it? If this cold, wet Mars existed billions of years ago, what kind of life could have lived there?
You've got me thinking about those extremophiles you mentioned earlier.
Yeah.
The ones that thrive in conditions that would be deadly to most other life forms.
Right.
It makes you wonder if similar organisms could have existed on Mars, making a life for themselves in those harsh environments.
Exactly. Imagine a world with vast, cold, and potentially acidic oceans. It challenges our Earth-centric view of life and forces us to expand our understanding of what's possible.
Okay, so let's talk about those Martian extremophiles. If they existed, what would they have been like? Are we talking about strange, alien-looking creatures or something more microscopic?
Well, if we look at extremophiles on Earth, they come in all shapes and sizes.
Right.
But when it comes to early Mars, we're likely thinking about microscopic organisms, single-celled life forms that could have thrived in those challenging conditions.
So no little green men, but possibly tiny little green microbes.
Exactly. Remember those psychrophiles we talked about earlier?
Yeah.
The ones that love the cold? They could have thrived in those icy Martian waters. It's mind-blowing to think about these tiny organisms just hanging out in frigid temperatures, perfectly adapted to their environment.
It's like they had their own little winter wonderland on Mars while everything else was freezing. But what about the acidity? You mentioned those acidic oceans. Could anything actually survive in that?
Absolutely. On Earth, we have acidophiles that thrive in highly acidic environments. Some even prefer a pH level lower than 2.
Wow.
Which is about as acidic as lemon juice.
Whoa, lemon juice. That's hardcore. I wouldn't want to swim in that. How do they manage to survive in such extreme acidity?
They've evolved some incredible adaptations. Imagine having special pumps and enzymes that help regulate your internal environment, keeping you comfortable even when surrounded by incredibly acidic water. It's like building your own little oasis within a hostile world.
So they created their own tiny safe spaces within those acidic Martian oceans. That's amazing.
It is. And don't forget about halophiles, the salt-loving organisms. We find them in places like salt flats and the Dead Sea on Earth. They've evolved to thrive in incredibly salty environments.
Okay, so maybe no Martian margaritas.
Right.
But definitely a lot of salt. But wait, wasn't early Mars supposed to be cold and fresh water? Where would these salt-loving organisms have hung out?
You're right. But even on a cold and wet Mars, there could have been pockets of higher salinity. Imagine isolated lagoons where water evaporated, leaving behind concentrated salt deposits. Or think about what happens when water freezes. The salt gets left behind in the remaining liquid. Mars is a diverse planet, and conditions would have varied across its surface.
That makes sense. So we've got these incredible extremophiles, the cold-loving psychrophiles, the acid-tolerant acidophiles, and the salt-loving halophiles. Are there any other types we should add to our list of potential Martian inhabitants?
Well, there's one more category that's particularly intriguing.
Okay.
Polyextremophiles.
Polyextremophiles.
These are the ultimate survivors, the ones that can tolerate multiple extreme conditions at once.
Right.
They can handle the cold A&D, the acid, or the salt A&D, the heat. Talk about being tough.
Wow, those are like the superheroes of the microbial world, surviving in cold, acidic, salty water. That's like winning an extreme survival reality show. It makes you realize that life is far more resilient and adaptable than we often give it credit for.
Exactly. And that's why the search for life on Mars is so captivating. If life could exist in such harsh conditions on Earth, it's not unreasonable to think that similar life forms might have evolved on Mars as well.
Okay, so we've explored these amazing extremophiles that could have thrived on early Mars. But how do we actually go about finding evidence of them? It's not like we can just send a microscope to Mars and start looking around, right?
Right. It's a lot more complicated than that. Scientists have to be incredibly creative and resourceful when searching for signs of past life on Mars. They rely on a combination of sophisticated instruments, clever techniques, and good old-fashioned scientific detective work.
So it's like a Martian CSI episode.
Exactly.
What kind of tools and techniques are they using to crack the case of ancient Martian life?
Well, one approach is to look for those biosignatures we talked about earlier, those telltale signs that life was once present.
Okay.
Remember, it's not just about finding fossils,
Yeah,
although that would be amazing.
it would.
Scientists are also looking for things like specific chemical compounds, patterns in rock formations, or even subtle variations in the composition of the Martian atmosphere.
Okay, I'm starting to see how complex this search really is. But let's go back to those biosignatures for a minute.
Okay.
Can you give me some specific examples of what scientists are looking for?
Well, as we mentioned before, organic molecules are a big one. These are the building blocks of life as we know it, and finding them on Mars would be a strong indicator that life could have existed there.
Right, because organic molecules are like the ingredients in life's recipe book. Finding them on Mars would be like finding a pantry full of flour, sugar, and eggs. It doesn't necessarily mean someone baked a cake, but it certainly raises the possibility.
Exactly. And then there are isotopic ratios. Remember, those are like fingerprints that can tell us whether certain elements were processed by living organisms. Finding unusual isotopic ratios in Martian rocks or soil could suggest biological activity.
So it's like looking for a specific signature that only life can leave behind. That's pretty clever.
It is. And then there are certain mineral deposits that can provide clues as well. For example, stromatolites are layered structures formed by the growth of microbial mats, and finding similar structures on Mars would be a strong indicator of past life.
Okay, so we've got organic molecules, isotopic ratios, mineral deposits. Are there any other biosignatures on the Martian Most Wanted list?
Yes, scientists are also looking for atmospheric gases that can be produced by biological processes, such as methane. Methane can be produced by both geological and biological activity. So it's not a slam-dunk biosignature, but it's definitely worth investigating.
Right, because if we find methane on Mars, we need to figure out if it's coming from Martian microbes or just some geological burp. So how do scientists differentiate between those possibilities?
That's where things get really interesting. They have to analyze the isotopic composition of the methane and look for other clues, like the presence of other gases that are often associated with biological activity. It's like piecing together a puzzle using all the available evidence to determine the most likely explanation.
It sounds like a real detective story with Mars as the crime scene and scientists as the investigators. But here's the million-dollar question. Has anyone actually found any conclusive evidence of past life on Mars yet? Have we solved the mystery?
That's the question that keeps everyone on the edge of their seats. And the answer is not yet. We have tantalizing hints, intriguing clues, but no definitive proof.
Oh, come on. You're killing me here. Give me the details. What are the most promising hints we've found so far?
Well, one of those exciting discoveries came from the Curiosity rover.
Okay.
It detected methane in the Martian atmosphere, which, as we discussed, could be a sign of biological activity, but it could also be from geological processes.
Yeah.
So we need more information to know for sure.
Ooh, methane. That's exciting. But didn't you say methane can also be produced by geological processes? So how do we know if those Martian microbes are actually responsible?
That's the challenge. Curiosity also found organic molecules in Martian rocks, which is another potential biosignature. But again, these molecules could have formed through abiotic processes. It's like we have the ingredients for life, but we haven't found the recipe book yet. We need more evidence to connect the dots.
So it's like we have the pieces of the puzzle but haven't figured out how they fit together yet. We're still searching for that missing link, that one piece of evidence that will solve the mystery once and for all.
Exactly. And that's why future missions to Mars are so important. The Perseverance rover is currently searching for biosignatures in Jezero Crater, which is thought to have been an ancient lake bed. And get this, Perseverance is also collecting rock and soil samples that will eventually be brought back to Earth for further analysis.
Well, wait a minute. We're bringing Martian samples back to Earth. That's like the ultimate space souvenir. Tell me more about that mission.
It's called the Mars Sample Return Mission, and it's a joint effort between NASA and the European Space Agency. The plan is to launch a spacecraft to Mars that will collect the samples Perseverance has cached and bring them back to Earth.
Okay, that is seriously cool. So we're talking about analyzing actual pieces of Mars in Earth labs. That's got to be a game changer for our understanding of the red planet.
It is. Having those samples here on Earth will allow scientists to conduct much more detailed analyses than are possible with robotic missions. They'll be able to use the most advanced instruments and techniques available to scrutinize those samples, looking for any signs of past or even present life.
So imagine this. We bring those Martian samples back and boom, we find definitive evidence of past life. Microscopic Martian fossils preserved for billions of years finally revealing their secrets. Talk about a scientific mic drop.
That would be incredible. It would revolutionize our understanding of life in the universe and our place within it. We would no longer be the only known example of life in the vast cosmos. It would spark a wave of new research and exploration as we strive to understand the nature and diversity of Martian life. Imagine the headlines. Life on Mars confirmed. We're not alone.
It would be a defining moment for humanity, but even if we don't find fossilized Martian microbes in those samples, there's still so much we can learn from them, right?
Absolutely. Analyzing those samples will provide a wealth of information about the Martian environment, its history, and its potential for habitability. We'll gain a deeper understanding of how Mars evolved, what conditions were like billions of years ago, and whether it ever had the potential to support life.
So it's a win-win situation no matter what we find. Either we make history with the discovery of Martian life, or we gain valuable insights that will guide future missions and research.
It's exactly. The Mars Sample Return Mission is a testament to our relentless pursuit of knowledge and our desire to explore the unknown. It's a symbol of our commitment to unraveling the mysteries of the universe and searching for answers to those fundamental questions about our place in the cosmos.
Okay, this conversation has been mind-blowing. We've gone from talking about the color red to exploring the possibility of ancient oceans extremophiles and even bringing Martian samples back to Earth. But before we move on to the next part of our deep dive, I have one last question.
Okay.
What does this all mean for the future of Mars exploration? What are the big questions that still need to be answered?
Well, as you can imagine, finding conclusive evidence of past life on Mars is still the holy grail of Mars exploration. It's a question that continues to drive scientists and inspire missions.
Right, finding those Martian microbes would be a game changer. But what if life on Mars isn't just a thing of the past? What if it still exists today, hidden beneath the surface away from the harsh conditions above?
That's a question that keeps a lot of scientists up at night. Could there be pockets of life still clinging to existence beneath the Martian surface? Maybe in those underground aquifers or hydrothermal vents we talked about earlier? It's a tantalizing possibility.
Imagine a whole hidden ecosystem on Mars, thriving in the darkness beneath our feet. What would those life forms be like? Would they resemble anything we know on Earth, or would they be something completely alien?
That's a question we can only answer by exploring further, and that's precisely what future missions will aim to do. We need to drill deeper, both literally and figuratively, to understand the full potential of Mars.
Okay, so we need to send some spelunking robots to Mars equipped with the latest technology to search for those hidden ecosystems. I'm all for that. But what about the big picture? What about human missions to Mars? Is that still a dream, or is it something we might see in our lifetime?
Human exploration of Mars is still the ultimate goal, and agencies like NASA and SpaceX are actively working towards making it a reality. Imagine humans walking on Mars, conducting research, and perhaps even establishing a permanent presence on the red planet.
I can't even imagine what it would be like to be the first human to set foot on Mars. It would be a moment that would change the course of human history. But before we send humans to Mars, we need to make sure it's safe, right? We don't want to send astronauts on a one-way trip.
You're absolutely right. Safety is paramount. We need to develop technologies and strategies to mitigate the risks of radiation isolation and the harsh Martian environment.
Yeah.
It's not just about getting there, it's about surviving and thriving once we do.
So it's not just about planting a flag on Mars, it's about building a sustainable presence, a new home for humanity among the stars.
Exactly. And that's why research on Mars is so crucial. The more we learn about the planet, the better prepared we'll be for human missions.
This has been an incredible deep dive so far. We've covered so much ground, from the color red to the possibility of life beyond Earth, and you've given me a lot to think about.
I'm glad to hear that exploring Mars is like peeling back the layers of a cosmic onion. Every discovery reveals new mysteries and raises new questions. It's a journey of endless wonder and exploration.
Well, I'm definitely ready for the next layer of this cosmic onion. I'm eager to see what other mysteries Mars has in store for us. But for now, let's take a pause and reflect on everything we've learned so far.
That's a great idea. It's important to step back and appreciate the incredible journey we've taken so far. From the rust-colored surface to the possibility of ancient oceans and hidden ecosystems, Mars continues to captivate our imagination and inspire us to reach for the stars.
I couldn't agree more. And you know, it all started with a simple question. Why is Mars red?
It did. And look how far that question has taken us. It's a testament to the power of curiosity and the boundless possibilities of scientific exploration.
Well said. And on that note, let's take a break and get ready for the final part of our deep dive. I can't wait to see where this journey takes us next. It's amazing how much we've covered in this deep dive, you know. We started with that simple question, why is Mars red? And now we're talking about ancient oceans and extremophiles and even bringing Martian samples back to Earth.
It's been quite a journey.
It has, but there's one thing we haven't touched on yet. And it's something that's been on my mind throughout this whole conversation.
Okay, what's that?
It's the philosophical side of all this. I mean, the search for life on Mars really makes you think about our place in the universe.
Right.
If we find evidence that we're not alone, even if it's just microscopic life, it changes everything, doesn't it?
It absolutely does.
Yeah.
It would be a profound shift in our understanding of life itself. Think about it. If life arose independently on both Earth and Mars, it suggests that life might be far more common in the universe than we previously thought.
Yeah. It's like suddenly realizing your family is way bigger than you ever imagined.
Yeah.
We're not just these lone inhabitants of a tiny blue planet anymore.
Yeah.
We're part of this vast interconnected web of life that could extend across the cosmos.
Exactly. And it raises all sorts of fascinating questions. How did life originate on Mars? Was it similar to life on Earth, or did it take a completely different evolutionary path? Did life arise independently on both planets, or was there some kind of connection, some exchange of life-bearing material between the two worlds?
Whoa. an exchange of life between planets. Now, that's a mind-blowing idea. We're
Yeah.
talking about alien spaceships seeding life across the solar system.
Hey, maybe not spaceships. But there are theories about panspermia, which suggests that life could be transported between planets via meteorites or comets. Imagine a chunk of rock blasted off Mars billions of years ago, carrying microscopic life forms within it. That rock travels through space, eventually colliding with Earth and potentially seeding our planet with Martian life.
That's incredible. It would mean that life is even more resilient and adaptable than we thought. Traveling through space, surviving the harsh conditions of a planetary impact, and then thriving in a completely new environment. It's like the ultimate survival story.
It is. And it makes you realize that the search for life on Mars isn't just about finding those Martian microbes. It's about understanding the origins and interconnectedness of life throughout the universe. It's about piecing together our cosmic history and figuring out where we fit into this grand narrative.
You know, you're right. We started this deep dive talking about the color red, the rusty hue of Mars. But we've ended up exploring so much more. The history of water on the planet, the possibility of extremophile life, the search for biosignatures, and now the philosophical implications of finding life beyond Earth. It's like that color red was just a doorway leading to a whole universe of questions and possibilities.
It really is. And that's the beauty of science, isn't it? Every discovery leads to more questions, more avenues to explore. It's a never-ending journey of exploration and discovery, pushing the boundaries of what we know and challenging us to think differently about the universe and our place within it.
This has been an incredible journey, and I can't thank you enough for guiding me through it.
It's been my pleasure.
Before we wrap up, is there anything else you'd like to share? Any final thoughts for our listeners as they continue their own exploration of Mars and the universe?
Well, I think the most important thing is to remember that we're living in an extraordinary time. We're on the cusp of discoveries that could fundamentally change our understanding of life itself. And Mars is at the forefront of that exploration. So keep looking up at the stars, keep asking questions, and never stop being curious. The universe is full of wonders waiting to be uncovered, and who knows what incredible discoveries lie just beyond the horizon.
Well said. And on that note, we'll have to wrap up this deep dive into the mysteries of Mars. But remember, the conversation doesn't end here. Keep exploring, keep learning, and keep that sense of wonder alive. Because the universe is vast and full of possibilities, and we're just beginning to scratch the surface of what's out there.